Good morning, everyone. My name is Manuel Contreras. I'm a PhD student at Pontificia Universidad Católica de Chile and a visiting student in the CU building. I'll be presenting my research on the development of the failure probability curves for rod cut slopes with a particular focus in the variability in how influence the variability in reference patterns into the stability analysis. Failure in rod cut slopes are a critical issue, particularly in regions with intense rainfall patterns, intense rainfalls. As you can see in these pictures, the failure often lead to a significant impacts, in this case in the road network, causing a total or partial blocking of the traffic in the normal circulation. This can cause, at the same time, disconnected the communities and increase in the loss, increasing losses in the road users and at the same time in the road agencies. While various factors can contribute to these instabilities, hydrometeorological hazards is the main hazard that can cause the instabilities. Compounding this, we observing, for example, in Chile, is in the past years an increase in the failure of the cut slope due to the variability in the rainfall patterns. Here you can see a free body diagram of the situation. For one hand, we have the instabilities into the slope. We can cause a disbalance in the forces, the resistance forces. In the resistance forces inside the slope that can cause the instability of the slope, and then when the slope fails, a displaced volume blocking the slope and cause the second situation of this project is that when the traffic is interrupted and it causes traffic disruption, traffic variabilities and a rally cutting of the traffic. A first key point to understand that is how we can estimate this slope stability. A common methods are the limit equilibrium methods. When the slope is simplified into different slides to obtain the failure observed due to the disbalances in the resistance force and the Abertoni forces. Another numerical method is the finite element method. It's a most complex method when the slope is divided into a mesh, and we can estimate the disbalance not into the more than the forces, into the stresses and the strain at the different nodes that compose these measures. Another key point to understand what is a fragility curve. This research is another project. When the objective of this project is to estimate the risk of traffic disruption caused by these cut failures. So, one form to represent the physical vulnerability of this cut slot failure are the fragility curve. It's a probability approach when we include the uncertainties for the hazard, or from in this case the asset, the cut slot, to represent a probability of failure or a probability of the damage state as a function of for example, a rainfall duration, the amount of the total rainfall. This to represent the hazard intensity of this process. Another key point is how we can characterize the hazard, in this case the rainfalls. We need to understand how is the hazard into the study area. In this case, we analyze the recorded data of precipitations, then how we can randomize this event considering its variability of these rainfall patterns. So we use the KNN algorithm to randomize this event and obtain, for example, for a same rainfall period, different rainfall patterns to identify these rainfall events. This project, as I said previously, is a part of a big project divided into two stages. The first stage is about this presentation, is the stage when we estimate this fragility curve to represent the physical vulnerability of the cut slug due to the rainfall hazard. And the second stage is when we estimate the risk of the traffic disruption caused by this volume who display for the failure of the cut slopes. So the first stage is divided first. We model the rainfall, then we characterize the slope into, for example, its geometry, its soil type, and then we develop a slope stability analysis to estimate, in this case, the factor of safety of this slope, and then we estimate the probability curves, in this case, fragility curves. To the first approach of this project, we use the Bio region located in the southern Chile. It's a specific region we have that have a specific rainfall events with a total amount rainfall of 50 inches. And at the same time have a different variability in topography. You have mountains, valleys. In this study area, we find at the same time in the past, for example, the past winter event, about 300 events reported emergencies for the cut slug failures. We carry out at the same time an inventory of the cut slug in the main road in this study area, and found about 1,000 slopes with different angle inclinations and different heights. The recorded data of this study area, we generate about 1,000 rainfall scenarios for every weather station in the study area, that we have 16 weather stations for different return periods to 5 to 500 years. How we can see in this graph, for the same return periods, we can identify different rainfall patterns variable with rainfall intensity, with variability in the rainfall intensity and at the same time in the rainfall duration. And we integrating that, we can identify a difference, total amount of rainfall for the same return period. To the slope characterization, first we identify two slopes with different angle of inclination, soil type, and different heights to develop the first curve to develop the first approach of these curves and estimate the fragility curves. We carry out different field work and tests in laboratory to estimate the property of the soil and the properties of the cut slope in the study area. For example, we estimate the water level into the slope, the soil stiffness, the angle of the friction angle of the soil in laboratory, the soil density, and different parameters that we will use in this slope stability analysis. When we do the stability analysis, we develop a model into a Plaxis 2D software to estimate that factor of safety to represent how due to a certain rainfall event, how the water infiltrated into the slope, and how they change the property, for example, the saturation or the pore pressures into the slope to estimate that factor of safety. We define that the cut slope fail when the factor of safety is equal to 1. In this graph, we can see how the variability in rainfall patterns change. For example, the time when the failure occurred. For the same return period, we have different time of failure. Variability, for example, 2 hours or 2 hours or 3 hours in some times. That is important because this influence is is taken into account when we develop the fragility curves. Then finally, we estimate that fragility curve for the slot 1 and the slot 2 of this study, of this case study. And in this case, the fragility curve represents the increase of the probability of failure due to a rainfall intensity represented by the total amount of rainfall. So when we have, for example, a return period of 500 years, it's more probable that the slot failure than 5 years return period. And at the same time, we have different probabilities for different geometries and type of slope of different, in this case, for different slopes. Then, having that, we extended our model to all the scat slope in the study area, collecting soil information about that, the soil properties, and we developed those parametric curves to represent the probability of failure with different, in this case, with different type of soil defined about sand, soils, and clays. In this case, I'm presenting for the same height, that is 33 feet, but different inclination angles. That is a practical application. The practical application of this is to obtain, for example, given information of the cut slope in some study area, we can identify the hotspots which can be influenced for a center rainfall event. We can identify the probability of failure with different cut slope. So, as conclusion of this research, we estimate that fragility curves to represent this probability of failure due to a certain rainfall event. The practical application is to estimate, for example, for planets, where the hotspots of this hazard will come and to define, for example, mitigation strategies to improve the performance of this cut slope who file for a center rainfall event. I want to thank for the research project who support this research and the different institutions who supported with information, for example.
Having rainfall events to test your model?
Can you repeat, please?
You had any rainfall events to test your model?
A rainfall to test the model? We tested the model with a rainfall in the year 2023 to validate the model, because due to this, in this case, due to this event, a lot of has a lot of failure. So we validate the model with this information. It's validated. Thank you.